Today we are going to go over Unit 2 and we are going to go over Lessons 6, 7, and 8. Lesson 6, the objectives, is so you will be able to explain how checking accounts work and you will also be able to write a check. Let's go over some definitions first. First term is reconcile, which is to compare your check register with your bank statement to make sure that they agree. Checking account is a deposit account held at a bank that gives you convenient access to your money. Check register is a record of checking account deposits, withdrawals, and electronic transfers. A check is a paper document directing a bank to deduct money from your checking account and make a payment to the person named on the check. So writing a check, there are a few steps. The first step is you want to write the date, and keep in mind that all writing should be in pen. Second step is to write the name of the person or organization to whom payment will be made to. Step 3 will be to write the amount of the check as a numeral. Step 4 is to write the amount of the check in words with cents as a fraction of a dollar. Step 5 is to make a notation on the memo line to indicate the check's purpose. And step 6 is to sign the check. So keep in mind that you can do these in any order you like, but for this presentation, these are the steps that I will take. So here is an example of a check. First thing you want to do is go ahead and write the date. So I am writing out August 11th, 2015. So you want to make sure you write a current date. The next step is to write the name of the person or organization to whom payment will be made. So I am writing a check to one of my hardworking students. The third step is to write the amount of the check as a numeral. So that goes in this little box to the right side, and I put $523.78. So the next step is to write it out in words, and keep in mind cents will be written as a fraction of a dollar. So we write out 523. And then to separate the dollar amount and the cents, you want to write the word and then because it is 78 cents, you would write 78 over 100. Keep in mind, you do not write the word dollars or the word cents. The 78 over 100 is implied it is cents, and the dollar word is already there, so you do not have to worry about that anymore. Step 5 is to make a notation on the memo line to indicate the check's purpose. So this one you don't have to do, but it's always good for you to come back later and remember what the reason was for the check. So for me, the memo is for being amazing. And then the last step, the most important part of this check, is your signature. So that's my signature right there. Keep in mind, it is your signature. You're the one who wrote the check. You need to sign it. All right. So I want you to take a minute, try out this question, and then resume when you are ready. All right. So this one right here is going to be written as 1,204. Then we put the word and between the dollar and the cents, and then for 87 cents we write 87 over 100. So that's all I write on that line. Alright, so here goes another one. I want you to pay attention. We're going to do this kind of together. You're listening to it, but I want you to think of the answer before before you listen to me. So this first one is a signature. So because it is a signature, it should go where the letter F is. The next one is the name. So that is going to go where the letter B is. Next one is the amount, and because it is just a number, we want to put that letter C. That right there is a memo, so we are going to put that in part E. That's a date, so that goes in part A. So remember, those are what you have to put in there. I forgot one last one. So keep in mind, do you see how it is 208.00, and because of that, we can simply just write and 00 over 100. Alright, balancing your account. The balance is the amount of money in your account. So when you write a check or electronically transfer funds out of your account, you subtract the amount from the previous balance. When you make a deposit, you add the amount of the deposit to the previous balance. Because remember, you're depositing, meaning you're putting money into your account, and because of that, you need to add. So here's a formula that I want you to write down, or better yet, two formulas. They're very similar to each other. It's just one is for taking money out and the other one is for adding money in. Alright, here is an example. Stephanie Martinez checking account had a balance of $657.04. She wrote a check to pay her credit card for $245.31 and a check to her babysitter for $150. What is the new balance she should have in her check register? So we know that she's taking money out, right? Because she's paying for something. So we're going to subtract those amount from her current or old balance. So keep in mind, she had two different spendings. She had the credit card for $245.31 and a check for her babysitter. So together she spent $395.31. So we take that number, we subtract it from her old balance, giving us a new balance of $261.73. Here is another formula. This one again is very similar to the other one. This one is just a little bit more in details with different kind of credit and different kind of debit. So here's an example. Jennifer Ibarra received her bank statement. What is her current bank statement? So we're going to use that formula. Keep in mind, when we're withdrawing something, that's like writing a check because we're pulling that money out of our account. And service charge is paying the bank for holding your money. That's a minus also because you're losing that money. And then interest will be plus because they get to spend your money or they get to hold it, so they should give you some money as well. So some banks don't give you interest, make you pay for service charge, or vice versa. They will give you interest and don't pay you depending on what the requirements are. Alright, so what we're going to do is plug in all the numbers, and then we're going to use order of operation to get to our final answer. So because it's all plus and minus, or subtraction and addition, we're going to go ahead and work from left to right. And when we do that, we get the final answer of $854.99. Alright, I want you to take a minute to try this question out and then resume when you are ready. Alright, so again, same formula we used previously. We're going to plug in everything we know, $1,264.32 plus $648.18, and then minus 578.64 minus 4.59 plus 2.68, giving us a total of $1,331.95 as the balance. Alright, now we are going to go over bank reconciliation. So here's one formula. It's the same one as before. Again, this time just different terms so that you get used to it. This one, same thing, adjusted balance and then the present balance. So take a second to go ahead and write that down. Alright, now let's go over an example. So this right here is Kevin's bank statement. His previous balance was $246. So according to the statement, what is his present balance? So we're going to go ahead and use that formula. So present balance, remember, it's the previous balance minus any kind of withdrawal. So that could be charges and that could be checks. Plus any deposits that we get or credits. And then minus the service charge. So we plug in all the numbers. In order of operation, let's go ahead and do what is inside the parenthesis first, giving us $246 minus the first set of parentheses is $501.43. Second set of parentheses is $608, and then minus 4.27 from the service charge. So the balance is going to be, let's see, $348.30. And Kevin's balance would be $348.30. So I'm going to show you a different way. This is a little bit longer, but I just want you to understand how that works. So the top, we know the previous balance was $246, and so we're going to subtract from that row the $78.34 because that is a charge, and then plus the $364, which is the credit. And when we do that, we get $531.66. So then we put that in the next row for the previous balance, and then again, same thing, minus 164.25 plus 164, giving us $531.41. So we put that again for the next one, minus the charge of $258.84 plus the credit of $80, and that gives us $352.57. We minus $4.27 from there. So if you do that, your final answer should again be $348.30. So if you notice, that way was a lot longer because we had to do one row at a time, or you can do what I did the first time and just put them all together. Alright, here is another example. Andre Jones' statement balance is $597.21. He has two outstanding checks for a total of $264.25. What is Andre's adjusted balance? So formula is adjusted balance equals statement balance minus outstanding checks. So the two checks together made a total of $264.25. So we only have to write it once. If the question had said he had two outstanding checks for $264.25 each, then you want to multiply that number by 2. But because it is a total, you don't have to do that. Alright, so we subtract the two numbers and we get a total of $332.96 in his bank account. Alright, now I want you to try one out on your own and then resume this video when you are done. Alright, so let's go ahead and go over this question. Again, same formula. We're going to plug in everything we know, which is 367 minus parenthesis, and then add up all the check and charges together, and then plus the other set of deposit and credits together, and then minus the service charge. The first set of parentheses gives you $734.75. The second set gives you $700. So then from left to right, we should get the final answer of $329.27 as the final answer. Alright, let's go ahead and go over lesson 7 now. We have objectives. First one is you will be able to solve problems involving simple interest, and you will also understand how savings account work and demonstrate the relationship between simple interest and linear growth. Here are some definitions. A savings account is a specific kind of savings account that earns interest. A principal is the amount of money earning the interest. Annual interest rate is the percent of the principal earned as interest in 1 year. Interest is the amount of money paid for the use of a lender's money. Simple interest is interest paid only on the original principal. Simple interest is the money paid only on the principal, which is the amount you put in. The formula for finding simple interest is I equals to P times R times T. I stands for interest, which is the amount of money earned on top of the money that was deposited or borrowed. P is the principal, or the amount of money borrowed or deposited. R is the rate of interest per year. They will give you a percentage. You need to change it to a decimal. T is time in years that the money earns interest. So let's do a quick review on converting percentages to decimal. So keep in mind, in order to convert percent to decimal, we must divide the percent by 100. So for example, to convert 78% to a decimal, we divide 78 by 100, giving us 0.78. So another way of looking at it is moving the decimal place 2 to the left. So that's a quicker way. Remember, if it's 78, that's a whole number, so there's an invisible decimal on the right side of the 8. So there is a decimal. What we want to do is we want to move it 2 over, giving us the same thing of 0.78, and that's what we got the first time as well. Here is an example. Nicholas deposits $500 in a savings account at Bank of America. The account pays an APR of 2.6%. He makes no other deposits or withdrawal. After 6 months, how much simple interest does his money earn? So we are looking for interest. So because we're looking for the letter I, we need to know P, R, and T. So P is the principal, which is how much he deposited. That's 500. R is 2.6%. Convert that to decimal, giving us 0.026. And then T, remember time is in years, but because the question is saying 6 months, we want to divide 6 over 12 because there are 12 months in a year, and that should be 0.5. So if you write 0.5, that's even better. So now we plug in everything we know. All we have to do is multiply them all together, and we get an interest of $6.50. That means after 6 months, Nicholas would earn $6.50 interest. Here's another example. Chelsea earned $211.60 in simple interest at 2 years at an annual interest rate of 4.6%. How much did she invest to the nearest dollar? So this time we're looking for how much she is investing, meaning how much did she put into the savings account. That is the principal. So we don't know principal, but we do know I, which is the interest, R, which is the rate, T, which is the time. Interest is $211.60. R is the rate of 4.6%, which is 0.046. And T is time. And again, remember, time in years. So they mentioned 2 years. We just put the number 2. Plug in everything we know. The goal is to solve for P, meaning we need to get P by itself. So before we can do that, we need to multiply the 0.46 times 2 together, giving us 0.092. Now, the goal is to get P by itself. So we need to use opposite operation to get rid of the 0.092. Keep in mind, right now we have multiplication. Opposite of that is going to be division. So we divide both sides by 0.092, giving us a final answer of $2,300. And it did say round to the nearest dollar, so that would be the final answer. Alright, now I want you to try one out on your own. Resume the video when you are ready. Alright, so this question is asking for the simple interest. That means we are looking for I. So we have to get P, R, and T. So P is the principal, that is $1,500. R is 0.045, and T is going to be 9 over 12, or 0.75. Plug in everything we know, and we get the simple interest of $50.63. Here is another practice question. Again, resume the video when you are ready. Alright, this question right here is asking for how much Nathan invested. That is P, so we have to get I, which is $435.20, R, which is 3.2%, or 0.032, and T is 4 because it mentioned 4 years. Plug in everything we have. First thing we need to do is multiply 4 times 0.032, giving us 0.128. Then now we divide both sides by that number, giving us a principal of $3,400. So that is how much Nathan invested. Alright, here's another one. I want you to try this one out and then resume when you are ready. Alright, for this one right here, we are looking for simple interest. So that's the letter I. We know P is 2200, R is 0.038, and T was the one that was a little bit tricky. So because the question mentioned days, we have to divide it by how many days there are in a year. And other than leap years, there are 365 days. So that's why we divide it by 365. So we plug in everything we know. 146 divided by 365 is 0.4, and that's why I put that in there. So the interest is going to be $33.44. So after 146 days, George would have earned $33.44 in simple interest. Alright, now we go on to lesson 8. So the objectives for lesson 8 is so you will be able to set up and solve problems involving compound interest. Let's go over some definitions. So this one isn't really a definition. I just want to let you know that we do have a compound interest table for some of the question, and really it's just a tool to calculate compound interest quickly. So there are going to be questions where they don't give you the table and you actually have to calculate the compound interest. The table gives it to you already. Compound interest is interest earned not only on the principal but also on the interest earned during previous interest periods. So it's really interest on interest. Balance is the amount of money you have in an account. So let's go over compound interest. This formula is for the table only, and that's why at the end it says times amount of $1. Alright, and compound interest, if we're given the amount, we can subtract the original principal from the amount to get the compound interest. So here are the steps, and again, these are only for the tables. Step 1 is to find the total number of interest periods. Step 2 is find the interest rate per period. And then step 3, using the table on the right side, we want to find the amount of $1 for blank periods at blank percent per period using the compound interest amount of $1 table. Step 4 is to find the amount, and then step 5 is to find the compound interest. So those question marks in step 3, I will show you what those mean. Alright, so let's go ahead and take a look at this question. Sophia deposited $6,000 into her savings account. She earns, or the money earns, 5.5% interest compounded quarterly. Considering no other deposits or withdrawals were or are made, how much will the account be worth in 1.5 years? We want to round to the nearest dollar. So first step, as mentioned in the previous slide, is to find the total number of interest periods. So we are going to use this formula. The total number of interest periods would be periods per year times how many years there are. So keep in mind that the money is earning or it's compounded quarterly. So quarterly is 4 times per year, and it is in 1.5 years. So there should be a total of 6 periods within the 1.5 years. The second step is to find the interest rate per period. To find the interest rate per period, we want to get interest rate divided by the periods in a year. Interest rate is 5.5%, and there are 4 periods in 1 year. So 5.5% divided by 4, giving us 1.375%, or converting it to decimal is 0.01375. And the second step is to find that on the table, right? So remember, it's 6 periods at 1.375% per period. So we're looking at 6 periods, so that row, and then the 1.375 column. So the amount for $1 is going to be 1.08538. That basically means for every $1 you put in, you're getting $1.08.538 back. Alright, so now we need to find the amount. So the original principal from the previous slide was $6,000, and we multiply that. So that means we should get a total of $6,512.28 after 1.5 years. So that is going to be how much your account is worth after after 1.5 years. Alright, compound interest formula. So earlier I gave you the table. This time we're going to have to find it ourselves. So this is the formula that you want to use, where A is the amount. Keep in mind it is also called future value. P is the principal, also called the present value. R is the rate per period. And we can find that using the formula annual interest rate divided by the number of periods in a year. N is the number of periods, and we can find the number of periods using number of years times number of periods in a year. So here are the steps, and remember, these steps are for the formula and not the table. First step is to find rate per period. Second step is to find the number of periods. And third step is to substitute all that information we found into the formula A equals P times 1 plus R to the n power. And the last step to find the compound interest is to take the original principal and subtract it from the amount. So here's an example. Kenneth deposits $3,000 in an account that earns 9% interest compounded monthly. How much compound interest will this account bear after 7 years? So remember, first step, find rate per period. So remember, rate per period is the APR, annual interest rate, divided by how many periods there are in a year. So because it is compounded monthly, that means it should be compounded 12 times in 1 year. So we get the APR, which is 9% or 0.09, divided by 12, giving us 0.0075. Now step 2 is to find the number of periods. Number of periods is the number of years times the periods per year. This right here is asking for the compound interest after 7 years, and number of periods per year is 12 because it is compounded monthly. So 7 times 12 giving us 84. That means this account will be compounded 84 times in 7 years. So the third step is to substitute into the formula. So P again is the principal, that's the 3,000. R is the rate per period, which is 0.0075, and N is the number of periods, which is 84. So we plug all of that in. Now we need to use PEMDAS to solve for A. PEMDAS, P comes first, so we need to do what is inside the parenthesis. So we add those together and we get 1.0075. Next is E, which is exponent. So we do the exponent, and 1.0075 to the 84th power gives us 1.8732096335. So I rounded to a lot of numbers. You can stick to 4 to 6 numbers and your answer should be accurate enough. So last step is to multiply them together, giving us $5,619.61. The last step is to find the compound interest, plugging it into the formula. So we get $5,619.61, and we're going to subtract $3,000 from that, giving us a final answer of $2,619.61. Alright, now I want you to try one out on your own and then resume the video when you're ready. Alright, first step, find rate per period. So this is compounded quarterly, meaning 4 times per year. And then the APR is 4.6% or 0.046, giving us the rate per period of 0.0115. Next step is to find how many periods there are in 9 years. Because it is compounded quarterly, we have 4 times per year times 9 years, meaning there should be 36 times. Step 3, plug it into the formula. So we do that, and we use order of operations, so do what's inside the parenthesis. Once we have that, we take the exponent, and once we have that, we can go ahead and get the value, and that's going to be $6,037.15. So that is the future value. For this one, we're actually done. Previous, we had to find the compound interest, but this question is asking for the future value, or the letter A. So we're done with that. Alright, and that is all that we have for today. If you have any questions regarding anything on this PowerPoint, feel free to reach out to me and I will gladly go over this with you.